Good day. Welcome to our um, lesson 4 for chapter 1. And chapter 1 talks about sets. In lesson 1, we talk about how do we determine if a certain collection can be considered a set or not. In lesson 2, we talk about um, how do we define a certain set in two ways, and that is the set builder notation and the raster method. In lesson 3, we learned about empty sets, the sets without any elements, and equal sets, those two or more sets with exactly the same elements. So in chapter 4, we will talk about finite sets and infinite sets and what are they. So in this one, we have two sets, set A and set B. Set A is the set of natural numbers less than 5. To recall, when we say natural numbers, these are numbers we use in counting 1, 2, 3, 4, and so on. So here, if you're going to list down the elements of A, we will eventually have natural numbers less than 5, 1, 2, 3, and 4. So in B, we have natural numbers greater than 5. As you can see, in B, the difference is clear. We have 1 greater than 5, that's 6, 7, 8, 9, 10, 11, 12. And since that's greater than 5, we need just to put ellipsis to note that the set continues up to infinity. So in this case, set A, the number of elements are countable. Okay? Meaning we can actually list it and we can finish by certain period of time. Okay? So set A is an example of finite set. So when you say finite set, these are sets with a finite number of elements. The elements are countable. Okay? In set B, this is an example of infinite sets. Infinite sets are those sets in which there are infinite number of elements within it. So we cannot actually count it and we cannot actually list it down by using roster method. So what we can only do is by defining it. So that's it. So let's try determining if these sets are either finite or infinite. So we have odd numbers from 3 to 17. Obviously, we can list down and we can count the number of odd numbers from 3 to 17. So that makes it a finite set. Number 2, we have even numbers greater than 50. So if you're going to do that, we have 52, 54, 56, 58, 60, 62, and so on until infinity. And we cannot really count it. So that makes it, this is an infinite set. So here we have prime numbers greater than 10. So the first prime number greater than 10 is 11, followed by 13, followed by 17, followed by 19, followed by 23, followed by 29, then followed by 31, and so on. So that makes this one also an infinite set. Number 4, we have days in a month. Okay, so obviously we can count the number of days in a certain month. That makes it a finite set. So when we say cardinality of a finite set, the word cardinality is just simply the number of elements in a particular set. Okay, so we need to count the number. We need to count how many elements are there in a set, and that number is what we call the cardinality of that set. Okay, of course, there is no cardinality of an infinite set because obviously we cannot count the elements in an infinite set. So cardinality applies only to finite sets. So we have here A, the set A is the set of all even numbers less than 10. So if you're going to list it down, we simply have 2, 4, 6, 8, and this one gives us there are 4. We say that for notation purposes, we say that n of A to mean that n of A meaning the number of elements in A. Okay, this symbol means that the number of elements in A is simply 4. So this, in layman's term, we say there are 4 elements in A. There are 4 elements in A. So the number of elements in A is 4. So in B, we say the number of elements in B, set B, is how many months are there in a year? We have 12. So there are 12 elements in set B. So that's January to December. Okay? So that's simply as that. So that's cardinality. When you say cardinality, talking about the number of elements in a particular set. So here let's state the cardinality of this finite sets. So obviously 1, 2, 3 are finite sets because we can count their elements. So we have here set X is the set of all multiples of 5 less than 31. So if we're going to list down, we have 5, 10, 15, 20, 25, and 30. So that gives us the number of elements in set X is 6. Number 2, we have major islands in the Philippines. What are the major islands in the Philippines? The Luzon, Visayas, and the Mindanao. So it makes number of elements in Y is 3. So number 3 is Z. The set C. Z is the set of all prime numbers less than 15. So if we're going to list that down, the first prime number is 2, and 2 is the only even prime number. So next, followed by 3, followed by 5, followed by 7, followed by 11, followed by 13, and that's it. So there are 6 elements. So we say that the number of elements in Z is simply 6. So that is how we find the cardinality of a finite set.